Start recording. All right. Hi, Dr. Toddy. It's Ethan, and today we're going to go through project phase 2. Um, Looks like you just want us to go over the pearls and a little reflection on what we've done so far. So I've gone through, done some good EDA process, cleaned up the data, graphed it, and at the end I have some data pearls, which are just the graphs that I felt like really highlighted um, the data that I was able to compare. So our predictor predicted the y value is going to be average fare, and here we have a histogram and a box and whisker plot. I don't know. Okay, you can see right there. I know I'm in the way right here, so I gotta double check. Before it was very heavily skewed. So if I scroll up here real fast, very heavily right skewed. So um, I just took the 99% quantile, and we have a more uniform data. And the box and whisker plot, nothing out of the ordinary there. My next pearl is the average fare over time by quarter. So as you can see, as years go on, average fare really fluctuates. It looks like there wasn't much price gouging in the early 2000s, and then around 2010, there's a big spike in average airfare cost with the crash of COVID-19, and then it seems like around, I would say 2022, 2023, they got right back to price gouging us. So it looks like they're happy. So I think that's a good one. It doesn't really show that. It also shows that there's not really a major difference per quarter. Each quarter kind of resembles each other. The only one that's really different is number 1, and it has slightly more data. Not like enough, but like a couple thousand. I think like the other ones are like 60,000, and number 1 quarter 1 is like 62,000. So again, not much big difference on data. It kind of does seem like it's a little shifted, it's a little out of place. Like these ones perfectly aligned here, and this one's to the right a little bit. These ones perfectly aligned here, and it shifted to the right a little bit. So it could be an influx from quarter 1. Quarter 1 is what, January to spring, I think. I don't know if it takes in consideration the previous quarter or just the airfare during that, but really all there really is what, spring break. You think quarter 4 would have actually the most because of like Thanksgiving and Christmas and New Year's, but I'm not really seeing any kind of patterns with that. Next, gotta love the correlation heat map. We're looking at average fare, so we're looking along this. Yeah, you can see it good. We're looking along this row or this column. We can see that year has a 0.15 correlation to average fare. So as the years go on, we can see that it kind of has a positive trend on average fare, kind of increases as the years go on. Quarter has a negative 0.2, so I guess you could say that as the further you go in the quarter, price drops a tiny bit, but nothing significant. Miles between airports is a very great correlation of 0.5. So as miles rise between airports, there's going to be a correlation to having more of an airfare price, I guess. Been a long weekend in a week. So airfare, of course, is going to have a positive correlation of 1 to airfare. And then time index, that's my feature engineered feature. Gosh, I don't know. It's been a really rough week. That's 0.15. It's going to be the same as year because, as you can see, they're both 1-on-1. That's because time index is feature engineered from year, so they're going to go hand in hand. So they're practically the same. Moving on, I have two more pearls, and it's just showing the count by the airport. So this one we're looking at right now is the origin airport, and you can see there's a lot of airports that get heavy like heavy flights going out of them. And then down here, there's rarely some flights even coming into some of these. Um, so that's going to definitely affect the model. I think if we're looking at like if I'm trying to predict a model that's down here for how much is a flight from out of DCA, it's not going to do so well. Now, DCA flying in, um, it's gonna be able to predict a lot because it has a lot of traffic going in, just not a lot of traffic going out. And it's kind of the same thing where there's a lot of heavy um, traffic, and then there's just no traffic at all. You think that the top maybe 10 would be the same airports, but that's really not the case. Like there is some similarities, I think. Like LAX is on both of them. Nope, JFK. I think there was one that I saw. I should have wrote it down. But yeah, so nothing really out of the ordinary there. It's just we're gonna have some kind of data issue. And then one last thing I want to touch on was the record count by year. I didn't add it down there because I didn't think it was like that, like a data pearl. But we are missing 1995. I was like curious. I made this graph and then I saw that and I'm like, are we really missing 1995? So I printed out the length of the total count of how many records are from 1995, and there is 0. So for some reason, we're missing a fat chunk from 1994, and then 1995 is just missing. We are missing a fat chunk off 2024, and my guess is that's just when this data was stopped being collected, or the Kaggle. It could have been collected at 2024. But again, something happened here. We can see like really 9/11 didn't really impact flights because it's the same account in 2001, and 2020 there's a slight dip, but nothing major. Like you would think that 2020 might have the same impact as 9/11. However, there's really not any significant dips there. So I think I'm supposed to talk about the reflection. Reflection, I think I did pretty well cleaning the data. I don't know if I did exactly everything you were looking for, but I went through, I reviewed the value counts for each just to get a little more insight to what each kind of label is. Then I dropped columns. Oh, I forgot to remove my comments because I moved my comments down here. So each summary has like why I dropped the columns and why I dropped them. Because we went from 23 total columns down to I believe 7. So because some of the columns are just not needed for knowing why the airfare was before we know the actual airfare, because our goal is to predict before that quarter. So if I want to fly somewhere in say Q4 of 2027, I want to be able to look at previous years and try to predict that price. I'm not going to be able to have some of the data that this data set included. For instance, like passengers. Passengers is one where in my phase 1 I was talking about it'd be cool to see if passengers reflect the price. But then after this week we kind of did that. I think it was a video, one of the Stats Quest videos, where it said to make sure you're not trying to predict an outcome based on data you get after the outcome, and I kind of did forget that. So I made sure to only include variables that weren't going to do that, so we can have like a real kind of prediction model. Where is that? It's my final data sets right here. I have a clean one and a model one. That's just because we went over it, but average fare was really skewed. So I have 2 data sets. One's where it's like the clean one where I didn't remove that outlier, and a model one where I did remove that outlier, because I did want to graph it. All right, Dr. Cotty, that's phase 2, and I look forward to hearing from you. Thank you.